Welcome everybody. Welcome at this Getting Technical live event. And we are going to talk about circular economy in machining situations. And um, you know, it sets circular economy, but I'm more thinking into circular thinking in machining. And that is what we are going to talk today about. And the subtitle says also a very important thing, because very often, my experience at least, uh, when you talk about circular economy with people in the machining industry, um, people very often say, "Yeah, but we are small, medium-sized companies. We have very tight margins, and this type of thing costs a lot of money. Is this really something we should be doing?" And so on and so forth. There are quite some hesitations. And to be honest, I should not be gossiping about other people. Me also, in the beginning, when this thing started to be alive, circular thinking, circular economy in machining, I also was thinking, life is already so difficult in machining, and now on top of everything also this, is this really going to work, and so on and so forth. And I changed opinion in the meantime. Let me start by saying that. If I say I had doubts in the past, today I do not have any doubts anymore. And I'm really convinced that circular economy or circular thinking in the machining industry is not any longer an option. I think it's a must. But we have to do it in a correct way, and we should step away from the vague thing, and the slogans and stuff like that. We should, if we want to apply it with success, if we want to take full advantage of it in machining, we have to talk about making it really practical, measurable, and uh, make it that it contributes to the goals a company has. And the presentation of today is about why should we apply it in machining? Why should we do circular thinking in machining? What should we do is a second big subject. Because, okay, once we are convinced this is something which can be useful, the next question to be asked is also, yeah, okay, what do we do then? Do we start buying things, or what do we have to do if we want to apply the principles here, which are in that thing called circular economy? And once we know also what, of course, the final thing is, okay, how do we put it in practice then? It's the traditional way of looking to new things, because the experience I have in companies I work together with on this thing is that in the end, it's just opposite to what most people have as a starting idea. In the beginning, people think, yeah, it's going to cost a lot of money. For what? In the end, we learn, if you apply it in machining production, it's going to help you uh, to increase your profit. Very strange, perhaps, for some people now, but that's what we are going to talk today about. My name is Patrick de Vos. I'm your host today. I'm more than 40 years in the machining industry, kind of, one could say. And based on that experience I have, I have this type of presentations where I want to share with people all the things I could learn myself over the years. I'm not alone here. There are people helping me. Uh, with all the modern technology behind this, making this possible, that I talk to you on this medium and on this platform. And let me start already now, because I have a challenge today. My challenge is that this presentation, which is a reduced version of a seminar on the subject, but still the reduced version is more than 60 slides. So there's sometimes we will have to go fast just to respect the time frame we are working with. already now, that's why I want to tell you this now, that if you want to have a copy of this presentation, or if you want to have access to all the other things which we have been creating around this Getting Technical live events, just put it in the chat, send a mail, whatever. These things are available for further reference afterwards. And of course, this presentation has been recorded. You can review it afterwards on the different channels where it's available, including the SecoTools website. As an introduction, why does it matter? As I said in the beginning, me also, I had some hesitation when people were talking about this. And I'm very convinced that some of you have the same hesitation I had a while ago. Why do we need this? Why does it matter? Why is this important? Well, if we look to machining production, that's a very resource-intensive process due to the physics underlying the process. And it means that raw material, energy, tool integrity is dissipated in the form of chips and heat generation, tools deteriorate, and so on. So we have kind of a lot of transformations going on, which do not contribute really to the final goal of the process being a correctly finished workpiece, delivered in due time at a reasonable cost. That's one thing. The other thing is that machining is a process where a lot of things work together. You have energy input, you have cutting tools, you have coolant, you have the machine, which is capacity, you have people interfering with the thing. And all of these things come together in one situation, one machining process. And those things has to work together. And if that working together is not in the best form or shape, we are going to create things which are unwanted. We are going to have stops of the machines, we are going to break tools, we are going to create workpieces which are not in line with expectations. So it is a process where in the process itself we already create things we will call within a minute now waste. And on the other hand, there are so many elements working together in machining that if we don't control how the working together goes, that we are going to end up with a lot of unwanted outcome. Let me put it like this, a little bit more schematic, and this is perhaps one of the most important visuals, pictures in this presentation. We always look to machining as a process in which we put things in, energy and materials and people and time and money. We have input. We bring it together in a machining process where we do transformations to create output. And the output is finished workpieces. The outcome is also that perhaps if we do things right, we bought some extra time to do other things in production. Money has been created, hopefully. Profit has been made in this transformation process. We come out of the process with people with more knowledge, more expertise, more experience, on which we can use the next time we have to do something. And if you look to machining, very often people focus on this. How to create the best possible input, the blue part here, so that the process itself creates a maximum, the yellow-orange part here, a maximum output. And for a long time, we focused on that, and that another thing typical for machining, what I tried to say before with words, is that machining also creates a lot of waste. Side effects, side products, things like worn-out tools, things like badly produced workpieces, things like chips, things like we lost time. We planned for an hour, we had to spend 2 hours, so we lost an hour. We lost money because things happened that were supposed to happen. But it doesn't stop there. We also have gaseous waste. We also have liquid waste, coolant and stuff like that. We also have that energy has been used to create things we do not need. Sound, vibrations. All of these are a form of energy which is created during the process and which in the context of that the yellow part here is the why we do this process to create a workpiece. Yeah, a vibration is a waste of energy. Noise is a waste of energy. Heat is waste of energy. So and if you look to the picture here, what people do not always realize is that perhaps the waste created due to a machining process or during a machining process is perhaps more important. At least if you look to the picture here, it's a bigger red part than it is a yellow part. Um, Circular thinking, circular economy in machining is about the red part you see here in the picture. And how well we do this, we are going the next session we plan in this series of events is about the gray part you see in the bottom of the picture. If we start focusing on the red part now, or focusing is perhaps the wrong word. We should say if we include that red part in everything we do when it's about machining, not just focus on the blue part or the yellow part, but also take into account the red part, we should be able to measure what we do. And that is, then we start talking about things like cost performance ratio, energy performance ratio, cost performance ratio, risk corrected, and so on. But as I said, those metrics we can use to measure how well we do. That's for a next session. And this is not new. That ships are generated and ships are a waste and that tools are used out and worn out. All of that is as long as we do machining, we know that. But we kind of have been taking it for granted. It's part of the process. We can't help it. That's what it is. Now, why suddenly should we start thinking today on this? But there are a number of reasons. First of all, material and energy prices show a tendency to go up, but in a very volatile manner. They go up and down, and that makes that for a CEO, a company owner, to plan things in a little bit a longer period when it comes to his company and the goals and the targets he has, that volatility in prices of materials and energy he needs to do the process is a worrying thing. We have supply risks, tools, raw workpiece materials. You know, everybody wants to work without any stock, just in time philosophy. But that means that the least thing that happens, the supply chain is broken. And yeah, that means that we have issues there. There are, of course, the increasing demands from the society, from customers, that a company has to take its responsibility when it comes to environmental stuff, sustainability and things like that. Circularity is part of that thing. And competition is fierce. Meaning that the margins companies are running with are under very high pressure, especially when it's about SMEs, small and medium-sized companies. That means that limited or small margins, or at least saying margins are under pressure, that the cost factors are gaining in importance, and of course waste is a cost factor. It's things we bought, we had to pay for, and then it comes in and we throw it away. It's a cost factor that is not compensated by income. So these are some of the things that make that people start to have an open eye, an open ear for when we talk about circularity, when we talk about waste and how to minimize waste, how to avoid waste by recycling things and so on. So, in a changing world, for machining companies, especially the small and medium sized ones, which are running with small margins under pressure, it's a key element uh, to think at least about circularity. Um, and if a company starts doubting and say, yeah, perhaps, yeah, there are different levels if you want to start with this. And there is one level, I call it level 0. I didn't know exactly where to position it. But if people talk about circularity, people talk about waste, recycling, and so on, and people automatically turn their face towards the workshop, because that's where it all happens. And that's where we are going to do a lot of things. But what people forget is that in a company, it starts earlier. And you know, if you talk about circularity principles, circularity thinking, a lot of it starts even before a first chip is made. It starts in the real beginning. It starts at management level. It starts there where the company is in contact with the market, with its customers. It starts when people are making a quotation. Because if you make a quotation and if you start doing over promising, oh, we do this and we do that, and afterwards you can't make it happen, you created a lot of extra waste by doing that. Because if you promise a higher quality than what a company normally can supply, you are going to create quite, or relatively seen, quite a lot of work pieces which are not in line with expectations. With other words, they have to be thrown away. Material. It's very nice to talk about exotic material. I always love when people start talking about titanium alloys and super alloys and stuff like that. But the value of those materials is, or the price of these materials also is very high. That means that you have to be aware already when you make a quotation that if you have to scrap work pieces, that's going to be costing a lot. Tolerance decisions, making promises to a customer, yeah, we do this, we do that, without knowing what exactly you are talking about. You know, in machining, you can do whatever if you spend enough effort to it. But that means if you do more than needed tolerances, that's going to cost you in tooling. That's going to cost you in extra energy. That's going to cost you extra time. And then the question is, is it all really needed? Batch sizes. A small batch is a problem, but a very big batch is also a problem. I don't know. I don't think so many people talk about or think about what is the optimum batch size for my company. And if I have smaller batches in requests from my customers, that's going to cost things. Or if you accept a bigger batch than what is good for your company, some people say, I like big batches, then I'm safe for months. That's true, but on the other hand, that being safe for months means that the number of machines is also blocked for months. And if your other customers turn up in that period saying, I have a job for you, you will have to say no. And by doing that, perhaps you are going to lose customers. And once the big batch size ends and you stand there, then you could have a problem. Too small batches is costly, too big batches is dangerous from a company strategy perspective if you are not ready to handle them. Delivery promises. Of course, very typical in the subcontracting world of we do that for you. Tomorrow you have it. And then reality hits in and it's not tomorrow. Be careful with promises you made. How do you make your quotations? Are you aware of the consequences of the materials you are going to machine? What decisions do you take about tolerances and shapes and so on for workpieces? What's the batch size should we talk about? And what promises do you make to your customers when it comes to delivery? Are all things which, before you even start machining, that already will have an impact on circularity things, on waste generation or recuperation in your organization. You know, in that respect, and it's a very typical disease for machining, overdoing could be one of the biggest enemies there is in a machining production when it comes to circular economy. And you know, that brings me to a very important thing, that's people, because very typical in the mindset of a machining expert is doing better, trying to do better what is needed, just to prove I'm capable of doing this. It's all very nice, but we should think very critical about it. Because circular economy, circular thinking, and constantly overdoing just to prove I can do it, it's contradictory. And that's why further on in the presentation, I'm going to talk here and there about people and the role of people. So management, level 0 means that management constantly have to question things. Do we really need this quality? Do we really need this tool? Do we really need this delivery speed? Do we really need... Just question. Because it starts there. And this is I once found this at a customer on the wall in a poster. I loved it. I still kept it. If you demand aerospace quality for a garden shed application, no circularity system will save you. If you overdo it, it endangers everything, with other words. Now, the traditional levels of circularity, or sustainability for that matter, we can only make work when company strategy, applied technology, and the people working in the company are all working together to gain it. That means if we talk about circularity, management needs to be involved. I call that level 1. Engineering must be involved. I call that level 2. And operators in finally having to do things in a workshop needs to be included in the picture also. So that is the 3 classical parties or stakeholders involved in this. And if you can make those 3 work together, then you see that circular economy kind of becomes the same as operational excellence, which is a well-known metric when we talk about how good a production is running. Level 1, the strategic thinking. Circular economy should be part of the business strategy, I think. And especially for small and medium-sized companies, seeing the limited things they have available, people and budgets and so on, circular economy should not be treated like an ideology or a marketing stuff. It should be seen as something like risk management, and I explain later on, and something to increase the resilience of a company. And it's important for management, because if you play your cards well, it means a reduced dependency on suppliers. It means lower exposure to tool and material shortages, broken supply chains and stuff like that. And it means a better predictability of cost and delivery. With other words, happy customers. And you know, things like included in this is that management have to think about the tooling policy as a strategic decision, because, you know, leaving tooling choices, tooling selections in the hand of technicians without management before had decided a strategy on how and what do we expect from our tooling is the most dangerous thing any company can do. Once it comes to selection of carbide grades and geometries and nose radiuses and diameter, you can leave that to the hand of the technicians. But questions like, do I go for insert systems or solid carbide? Do I go for regrindable tooling models or not? Do I go for modular tooling? That are strategic decisions that needs to be taken by management upfront, all the other details for later on. Management should also look further than just purchasing costs. Management should look for life cycle cost analysis of their tooling. How much does the tool cost in the end, seen over its total life cycle? Management should start to realize that chips are not waste, but material inventory. If you machine titanium, a titanium chip is titanium. Nothing wrong with it, it's titanium. The shape of it is a little bit, unfortunately, a ship shape, but it is titanium. And management should think about what do we do with all those ships. Management should come up with KPIs that fit into circular thinking, like the cost for most people think in cost per hour. A machine costs X euro, dollars, whatever per hour. Nobody asks questions how much output is generated in an hour. A better KPI is cost per effective machine hour when things happened, cost per good part. If people talk about tool life, machining people, oh, they want long tool life, always want long tool life. Yeah, but what is long tool life? Is that the tool life of one cutting edge, or do you include regrinds, or do you include that an insert has more than one cutting edge, and so on? Energy should be considered per good produced part, not per machine, per hour or something. So KPIs should be rethought perhaps a little bit. And that brings me to the second level. That's the technical level, the technology level, the engineering department now we are talking about. Once management decides on a strategy, engineering should decide, okay, what do we need to do to follow the strategy? And if you think on machining with all the unpredictability leading to wastings, an unpredictable process leads to a broken tool, and a broken tool is pure waste, cannot be recycled, it does not fit in circular thinking. So we should not have broken tools. How do we avoid broken tools? And this is just an example, by making sure that our processes are stable, are predictable, are reliable. That's what we need to do. We should, or engineering should come up with how do we control tool utilization? How do we predict tool wear? How do we make that chip formation is on a constant, reliable form? How do we make sure our setups are repeatable so we don't have to reinvent the wheel each time? That is what engineering needs to do. And just some examples. Talking about tool life, engineers should stop thinking in terms of long tool life, optimized tool life. That's what you hear every day from them. It's much more interesting from a sustainability perspective, from a circularity perspective, to start talking about sustainable tool life. How can I make sure that every tool, again, in whatever setup, delivers the same tool life? That things becomes predictable. You know, a broken tool is pure waste. A well-used tool with a predictable tool life is an asset. Machining strategies, it's not the most brilliant one. It's not the fastest one. It's not the most sophisticated one that matters when we talk about machining strategies. It's about the ones that minimize power consumption or energy consumption. It's about the ones that create a stable process, that avoid vibrations, for instance. It's about avoiding machining strategies that lead to unpredictable wear patterns. That's what we have to focus on much more. when it comes to regrinding. I think regrinding is one of those things. Every company says, yeah, of course we should do that. We have to think circular. We need to regrind. And when do they do the regrinding then? Yeah, the operator decides. When the tool looks dull, it's time to regrind it. No. Regrinding, a very important thing when we talk about circular thinking in machining. Regrinding is something that we cannot leave by coincidence. We need to plan it. We need to decide when do we go for regrinding. And that should be fixed, and that should be known by everything. The same goes for recycling. Everybody talks about recycling. It's important, but yeah, I have some photos, and then, in a workshop you have somewhere a box, and then the instruction for the operators is, please, if you don't mind, a used up tool, a broken tool, you should throw in the box. And that's it. No, it doesn't work like that. Recycling needs to be a full part of how we run production, our production management. People, then we talk mainly about people in the workshop. I'm firmly convinced that equipment doesn't create circularity. It's not because you buy a new machine. It's not because you buy a new tool. It's not because you use a new software system that you will have suddenly circularity thinking in your company. It's people that make it happen. And perhaps the people closest to the reality are the operators. They will notice firsthand if things turn for the worst, if tool starts to break, if we see unusual wear, if ship forms is changing. So motivate them to give feedback on that, because the moment you have an operator giving feedback, it's as simple as that. You have circular thinking in the workshop. And give people trust. Don't if existing, stop with the blaming culture. So often I experienced it myself in a workshop. People report a broken tool, and the first thing is the blaming, the finger. What did you do? Didn't you pay attention? Why did you break the tool? Now, trust me, there's not one single operator, not at least the ones I met in all my years, that on purpose is going to break a tool. So no blaming. Listen with open ears to the feedback an operator is giving you. That is circular feedback, if you want to call it. If you want to introduce this in small batch production, very often small batch production is something you also find in SME companies. You find it in big companies also, but I want to focus here on small, medium-sized companies, because big companies, automotive companies, when they start talking about circularity, they create a department, they hire people, they have big budgets, and things starts to roll. But in small companies, medium-sized companies, small batches. That's also where people say, we don't know if this is something for us. From a circularity perspective, also, if you read up on circularity, you find a lot about to design for circularity. Now, it's all very nice, but a subcontractor, a small company working for another company, they do not design the workpiece. They receive a drawing and they have to deliver in line with what the drawing says. And people sometimes say, you see, we in our little company, we cannot do anything on circular because the part is designed. But these things, plus all those typical things of small batch production, the frequent setups, the changeovers, the high effort for setups, the trial cuts. They say, you see, it's impossible. And it's all true. But on the other hand, there are opportunities in small batch production because parts very often have a high value. Human expertise needed to do a job is high. Flexibility is a much more important thing in a small batch organization or small batch production than volume thinking. And these things are opportunities, because if we talk large batches and we talk about sustainability and circularity, then we talk about optimizing equipment. But if we talk small batches, what we have to optimize is thinking of the people. And from a manager perspective, that's perhaps the biggest challenge of all. You have to allow your people to think in this terminology. Uh, so for a subcontractor doing small batch production, it's not about designing the part for sustainability or circularity. It's about controlling what he can control, and that's the machining process. Uh, Circularity, in this respect, refers not to the design of the workpiece, but to the machining process, the machining production organization. And if you start doing things, another thing I hear very often with smaller companies, they say, yeah, but this is going to cost a lot of money, you know. And as you know, margins are already so very, very little. Let me introduce you to some of the tools we can use here. And I on purpose, I show a box with gold, but that's not what you need here. So I'm not going to show you investments that cost a lot of money and so on. Just some things to think about. Tooling is one of the fastest, very often also most underestimated levers you have to increase circularity. And a sentence you have to remember there, emphasizing the importance of management, is that if you leave every engineer to select his most favorite tool, that won't lead you to flexibility, circularity, or sustainability. The only thing it brings to you is the opposite, total chaos in a workshop. I said one of the things management needs to do when they forward circularity, sustainability as a more important part of their business strategy is they have to take first their responsibility and come up with a general strategy for the tooling used in the company. No details, not the carbide grades, not the geom, but the big things. Modular tooling, solid carbide tooling, insert type tooling, regrindable, yes, how often, where, that type of stuff. Handling ships, for a lot of people, they say, yeah, that's a waste problem, all those ships we have. Think differently. Your ships are a logistics problem. You are sitting on piles of valuable materials. How to use them in the best way possible. Think in terms of cooling. Coolant in the average workshop is very much neglected. It's only when it starts smelling people recognize, oh, there's still. Coolant management is an important thing. It's not just about hygiene and it's process stability. Circular energy use. Remember, a stable, a reliable machining strategy, in the end, even if it takes perhaps longer, will consume lesser energy than a very aggressive machining strategy. And a second remark there, machine idle times consume energy but do not create output. While the machine is standing still because she's in setup, the operator is solving a problem. The operator is trying to find the tool he needs. The operator is having a discussion about a strategy with an engineer if it will work or not. All that idle times, the machine is consuming energy and is not producing one single workpiece. Make sure that your machines, when they are on, they produce. When they are not producing, they should be turned off. Now, I put it black and white, it doesn't work like that, but minimizing idle times is a very big part in circularity thinking. How can I minimize my idle times? And don't start buying stuff. Don't start replacing equipment or machines. You only do that if you thought it through, and if you could identify that it is indeed the piece of equipment that created the problem. Perhaps you say that machine consumes a lot of energy, so we should replace it. But if you dive a little bit deeper, you find out that the machine is hardly producing workpieces, it's standing still the whole day. Yeah, your machine is not your problem. Your idle times are your problem. Knowledge. Knowledge is perhaps the most fragile circular resource or tool you have in your company. It's most probably the most powerful one, but also the most fragile one. Because people leave, and there goes the knowledge. Teams change, shifts change, learned lessons are forgotten, are not documented, are not given to the next group. If you want real circular economy, you have to make sure you have a system to collect and to share knowledge you have in a company. You must have feedback loops that things do not stay in silos, are not isolated, but shared with everything, with everybody involved in it. Training in that respect is a very important thing. And if you manage to work with these tools, and remember, you haven't spent one single euro or dollar or whatever on this. I basically was talking about thinking. Think on this, think on that, reconsider this, reconsider that. That's why I say circular economy should be perhaps be called circular thinking in machining production. Now, if you start working with that, you see that there are advantages, and the biggest advantage is that the advantages you notice are real, are measurable, are tangible. What you will see is longer and more consistent tool life, improved quality of finished workpieces, more predictable machining processes, so you have less issues with delivery time and angry customers on the phone and stuff like that. You have economical benefits, lower tooling costs. Uh, Lower scrapped workpieces, lower rework volume, fewer emergency situations in a workshop. So next to that, you have sustainability, because you will have a lower CO2 footprint in the end per part you produce. You will have reduced tooling consumption, energy consumption, and perhaps a very important one also, you have credible reporting. Because that's another thing. Often when I talk to people, I say, okay, circularity. They start talking vague. Yeah, we did with big things. Yeah, but what? All kinds, all kinds. Credible reporting. And that credible reporting is so important. If you can put hard figures forward to your own people, to your customers, to people doing auditing of your company, that's going to build image, trust, and human benefits. If you engage your people in this, you will see that as a bonus for you being in management, ownership and engagement will grow. If people see that what they daily do values, compliance becomes ownership. It's not about anymore I have to. No, it's about I want to. Things to be careful with. Seeing circular economy as a marketing tool to make publicity, my company is. No. In the end, you find yourself in very difficult situations. Very typical pitfall, smaller companies, limited margins, limited profit. They say, go for the cheapest. I say, here, cheapest tool, but it can be cheapest whatever. treating ships as waste. Ships are no waste. You just have to find the ways to make the ships valuable again and earn some money for your company. Ignoring cooling is a very typical pitfall. It's all things, the very attentive listener will say, yeah, but we knew that. And yes, but also do it is my message here a little bit. How do we start? Clear priorities, clear KPIs. Management has to come up with this. Tooling strategies like this. Machining strategies, we focus on this. And the big lines. Create the discipline to be in line and make sure you know how to measure what you are doing. Management creates the framework. Engineering has to plan for the usage, reusage, and stability and predictability of processes. Uh, and operators are the ones where it's all getting real. They also have to show the needed discipline to act in line with what has been decided that priorities are. And perhaps the most important thing for an operator to teach them is that you don't have to prove that you can do it. We believe you can do it. Just respect the specifications. That's what we need. Overdoing is the biggest enemy of circular thinking. From management, the biggest issue you can have is that the feedback coming to you consider it as complaints and react accordingly, and that's wrong. You should see feedback as circular intelligence. Your operators giving you the information, this and this and this and this, is not exactly going as we all planned it to go. If you talk about circularity, circular economy in machining, circular thinking, that's my preference, because for me it's not about buying new equipment, it's about thinking, rethinking stuff in machining production. But anyway, if you talk about these things, in small batch production, which is often also done in small and medium-sized companies. Not always, but very often. Those two go a little bit together. Small, medium-sized companies that are doing subcontracting. With other words, they do not design the parts they produce. They receive a drawing, and that's it. That's what they have to deliver. And if you do workshops, which I did several times, and if I say, okay, what are the problems you are going to be confronted with? Operators, engineers, managers in a small, medium-sized company, subcontractor doing machining. Well, you have here a list of things that are always coming back. I'm not going to read this. You can read it yourself. Most probably it's unreadable, especially when you are watching this on your iPhone or whatever smartphone. You can't read it. But as I said, a copy of this presentation is available. Just ask for it. But the list is very long. And I added to this also how you can recognize it. You know, if you walk around in a workshop, you should use your ears and your eyes and your fingers, and you can learn a lot. So how do you see these things? It's people telling you, or it's you observing certain things. But you know, each of these things, when you put it on the table, when you start thinking about it, in the line of what we talked here about for nearly an hour now, each of these also is an opportunity if you know how to play it right. And let me take the first one, tight margins. Every company owner from a small, medium-sized company will tell you, I'm open for everything as long as it doesn't cost money because my margins are like this. Fair enough. And in a situation like that, you will recognize it instantly because the manager will say, so small margins, that all that circularity thing, I can't carry the extra cost for that. And there you stand then. Now, if you think on circularity, in the light I have been talking here, circularity is about stable processes. Circularity is about predictability. Circularity is about not overdoing things. Circularity is about making sure you use your machines to the maximum. You don't have idle times. Little things like this. And the result of it will be, in the end, that you have lower costs. So the company owner says, I have small margins. He makes an objection based on that and he says, I don't have money for circularity stuff in my company. But I claim that if you do it right, introducing circularity thinking will create a situation that there is a release on his margins. And perhaps in a second phase, then suddenly there are some budgets available to do some more sophisticated stuff. You understand the meaning of this table? It's an objection, a problem, a challenge, an issue, whatever you want to call it, that people will bring forward as a thing that does not allow for circularity thinking. You will recognize it under a certain form in the second column, but if you think about it and apply the stuff we have been talking about here, suddenly it's an opportunity. And that is kind of the core of my message. All the things I have been giving was examples of stuff, but it's circularity, circular economy. One could say it's a bit the same as production excellence, but made even sharper than before, seeing the actual situation we are in today. I already said tight margins, unstable supply chains, highly demanding customers, limited resources, and so on. If you want to go this road, very important is that you realize that there are different phases here, different points of view. You have the technical point of view, you have the economic point of view, the sustainability thinking, and the people side. And each of these gives us tools we can use to improve our circularity. If you want to start small. Don't revolutionize your whole company. Start small. Select a pilot. One machine, one material, one customer for which you work a lot. Focus on life cycle performance. That's a basic in circularity. Don't focus on purchase price. Focus on the cost something takes over its total life cycle. Treat the typical waste factors, ships, coolant, used tools, broken tools, no, not broken tools, but used tools as assets. If managed well, you can give them a second life. Make sure that circularity is not an island. Circularity should not be limited to the boardroom. Circularity should not be found only in the engineering department. Circularity is not just a workshop thing. It's everything. And everything has to be included and needs to work tightly together with it. And start measuring everything. How stable are your processes? What are the true costs, also the hidden cost? How much real waste is generated in the company? How big is the sustainability, in fact? And you know, if you start doing that, you see that what is good for the environment, and it started all there. We have to take our responsibility towards the planet, the environment. What's good for the environment is also good for your bottom line in the end, your margin, your profit. And circular thinking gives us both. That's the big gaining in the end. Uh, Before we close here, I want to remind you that very soon in the UK there is the traditional ITI session. You know, SECO organizes on different places on different times gatherings where customers can meet people from the industry, partners from the industry, machining people, colleagues, and exchange thoughts. For those of you who are interested in this, yeah, very welcome there. It's a physical event. It takes place in the SECO Technical Center in the UK. Just a reminder, if you want more information, just let us know. We send you all the information needed. And that brings me to the questions section. Let's see. Ooh, wait. There is a question. Thank you for useful lecture. Please advise where I can get the technical information, the SECO technical books on metal cutting, and so on. Send us. I'm not going to send an email, and I send you, or leave a message in the comments, and I promise you to send all information you need, so you know where to find these things. Another question is: my customers very often change specifications. Yeah. And often it means that I must do rework or even restart the job. And that is, I have ambitions on circularity, nice, but those changing customer specifications is killing all my ambitions. Do I have situations? It's a well-known problem in subcontracting. You have a job, you start, and the moment you start, your customer starts calling, this is changed, that needs to be modified, and so on. This is all about customer relation in the end. You know, customers should realize that once you start producing, there are certain points of no return. Meaning that if you reach a certain step in your production to create a certain feature on the part, after that moment in time, when a customer wants to change that specification or that feature, it's going to have serious consequences in time, in cost, in whatever. And that should be communication with your customer. Customers should realize that there are points of no return, and perhaps it could be nice from you to inform your customer when the points of no return are nearly there. Kind of a last warning. Are you sure that this is what you want? Because from now on, if you change, there will be consequences. It's a communication thing, you know, and it's very typical in subcontracting. I know it's one of those things which are part of the game, kind of. But talking between supplier and customer can do already a lot here. Another question: from a circularity perspective, what is best tooling, solid carbide or insert type? Normally people say, then that's an interesting question. That's a good question. It is a good question, but it's a very difficult question. I mean, there is no general answer to this. Because it's very much depending on do we talk about tooling for turning, milling, drilling, whatever? Do we talk about small tools, big tools? There's lots of technical elements here that interfere. But what I can tell you is that the only real solution here to find out is one, base your decision on full life cycle. It's not, I take the example for an insert, it's not a 2 life per cutting edge, it's a 2 life per insert. Meaning so many cutting edges, so many 2 life per edge, and so on. It's not the 2 life of a new solid carbide milling cutter, it's the total 2 life of a new one plus X amount of regrinds you can give it. That's what I mean with total 2 life cycle. And then I think artificial intelligence approaches will make it quicker for us to figure out, but it's about simulating. And it's about running one, not in reality, I mean behind the scenes, digital if you want. Run one approach, run the other approach, and see what happens, and which one comes as the winner out of the contest. Of course, it also implies that you make sure that your machining processes are reliable. One of the head things I have been underlining throughout the presentation, I think, predictability, reliability, stability is all very important, because you can do the theoretical exercise first, find out this would be best. But if the reality then is unstable, unpredictable, and you break one solid carbide milling cutter after the other, there goes your theoretical exercise down the drain. Think full life cycle. Second, make sure that once you go for something, that applying it is done in a reliable, stable, predictable manner. Okay, one last question. All the other questions I will end later on in the chat. One last question. My workshop people claim that optimized machining processes are more important to improve profit than all those modern things. I already sent some. Anyway, those modern things like circularity or sustainability. How can I convince them on the contrary? Personally, I have no experience in machining, so I have to believe what my people tell me. That's a classic one. You know, most of the machinists today, they still have had their education in the context of mass production, meaning that in a lot of cases, their thinking is how to run a mass production in the best possible way. And that means applying automation and optimizing your processes. Simple. That demands time, people, money. But that's okay in mass production. Small batch production is a completely different game. We don't have the time, we don't have the budgets, and we don't have enough people to run big projects. So we need a different type of thinking. And that's what I hear here that you say from your people. Your people say, yeah, we have to optimize the processes. We need the best possible tool. We need this, we need that. And it's all about technical stuff. And if you start talking about circularity, with other words, you start talking about flexibility, sustainability, reliability, predictability, your people... We want, and now comes my second point, we want to prove you that we are the best machinist in the world. You ask for 2 microns, we give you 1 micron. Just to prove that we can do it. That's the second hurdle you have here. The first one is, and I think that, you have to give your people kind of a re-education to see things differently. Small batch production is not mass production. Small batch production is not mass production with smaller batches. It's a completely different philosophy. you will have to make that your people learn that. And the second thing is that they have to swallow their professional pride of, I show you I can do it. In a different way, perhaps. It's not about finding that last micron, but it's about making sure if you need to produce 5 workpieces and the tolerances are within 2 microns, that you end up with, you start 5 workpieces and you end up with 5 workpieces with the tolerance within 2 micron. Then a machinist is also proving that I'm able to do it. It's, yeah. But I'm happy with the questions. There are a few classic ones here. But now I have to watch the time. Because we are already a little bit over time. I hope this presentation gave you some levers to start working with. First, to think about, to overcome your own personal doubts, like I had to do. Oh, this is not for us. We don't have money. That type of stuff. Second, to start thinking about how can I involve engineering and tell them and convince them that we need to do this, we need to do that, and so on. And also the operators must be on board. That they know what is expected from them. It's not 1 micron tolerance, 2 is enough, but 2 should be realized on 5 workpieces. I hope you understand what I tried to say. Next session, we kind of continue this circularity thinking, but I'm going to dive more into how do we measure in the end if we did a good job or not. Because so far, one could say the presentation I have been giving you, I said circularity is not about slogans, but perhaps I was using a lot of slogans myself here. I know. But just to trigger thinking. The next session is about, okay, we do it, how do we measure now? That's going to be a session on CPR's thinking, cost performance ratios, cost energy consumption ratios, energy performance, that type of stuff. But I leave that for next time. I hope it was an interesting session. Once again, if you want to have more information, a copy of the presentation, just let us a message. We take care of it. The outstanding questions I didn't have time for to answer, I promise you to answer in the chat. I hope you had an interesting hour. We were happy seeing you here and are looking forward